Hello everyone, welcome to your channel Sukh Academy EduWorld. Today we will discuss next 15 questions of chemistry prelims exam of Geo-Scientist 2024. In the 76th question they are asking that the conductivity and the molar conductance of calcium fluoride at temperature 18 degrees Celsius. The conductivity is this and molar conductivity is this. This is specific conductance. This is specific conductance, okay? So we have to find solubility product for calcium fluoride. Okay. They are giving us, first of all, calcium fluoride can decompose into calcium 2 positive plus 2F negative. Clear? At initial, we can consider its concentration is 1, and after particular time, its concentration will be 1 minus S. This will be S and this is 2S. Okay. So solubility product will be concentration of calcium 2 positive and fluoride. This will be 2S square. Clear? So this will be solubility product constant. Now first of all we have to find solubility, which is our concentration. And to find that they are giving us specific conductance kappa and molar conductance is 200 Simon centimeter square mole inverse. Clear? First of all we have to find concentration, that will, you can also consider it as solubility by using this expression. Okay. The concentration will be kappa multiply 1000 centimeter cube per liter over molar conductance. Now fill the values. Clear? Simon will cancel out each other. And this is volume centimeter cube per liter. So we will left with 2 into 10 raised to power minus 4 mole per liter. So this is our solubility or concentration, that is 2 into 10 raised to power minus 4 mole per liter. Now we will use this value in equation number 1. In equation number 1, that is this, to find solubility product constant. S into 2 into solubility square. So after solving, we will left with this answer, but according to the question, according to the options, this will be final answer. Okay. 3.2 into 10 raised to power minus 11. So in this question, B is the correct answer. In the next question, in the given plot of conductometric titration of acetic acid versus sodium hydroxide, the area around point 1 is curved due to. Okay, so in this is a conductometric titration between acetic acid, which is weak acid, and sodium hydroxide, which is a strong base. Okay, and when acetic acid is reacted with sodium hydroxide, on adding sodium hydroxide, which is a strong base, highly ionized sodium acetate is formed, and thus the conductance begin to increase. Okay, conductance begin to increase up to this one point. Okay, up to this point, because we know that acetic acid is weak acid. Okay, and its dissociation is less. Its degree of dissociation is less than 1. Okay, and with increasing base, it will dissociate and with dissociation sodium acetate is formed, and that is highly ionized, and that's why conductance begin to increase up to this point, and we will get reaction like this. So acetic acid plus sodium hydroxide, sodium acetate will be formed plus water. Okay, so at this point up to around point 1, okay, the sodium acetate will be hydrolyzed. Okay, and after this, when acid is completely neutralized up to this point, further addition of the base introduces excess of fast moving hydroxyl ions due to sodium hydroxide. Okay, the conductance of the solution therefore begins to increase even more sharply than before. So this conductance will be increased, okay, after this point due to the presence of OH negative anions because of sodium hydroxide. But the acetic acid will be completely hydrolyzed, completely dissociate up to first point, and we will get a sodium acetate plus water. So at this point we will get hydrolyzed sodium acetate. So in this question there are four options. One is neutralization of weak acid with weak base. No, this sodium hydroxide is strong base. Okay, so first point is incorrect. In the second, hydrolysis of the salt sodium acetate. This is correct option because at this point we have to choose the correct statement about the area around the point 1, which is curved due to. Okay, so this area is curved due to, because at this point we will get sodium acetate in the hydrolyzed form. Okay, and next is suppression of the dissociation of the acetic acid. This is also incorrect statement because with increasing with adding strong base, dissociation of the acetic acid will not be suppressed, even it will be it will dissociate easily. Okay, so in the D part, poor conductance of acetic acid, this is also incorrect. So the correct answer of this question. In the next question, consider the following table showing the apparent transport number of cadmium 2 positive ion in cadmium iodide solution of different molarities. So different molarities is provided for cadmium iodide solution, and with the increasing molality of the solution, transport number of the cation, that is cadmium 2 positive, is decreasing. Okay, and for regarding this, four statements are provided, so we have to choose which one of the following interpretation is correct with respect to the table given above. Okay, so in the first case they are saying in diluted solution cadmium 2 positive ion migrates toward anode and iodide migrates toward cathode, and vice versa in the concentrated solution. This statement is incorrect. Okay, so in the diluted form, cadmium iodide dissociates into cadmium 2 positive plus 2 iodide negative, and cadmium 2 positive moves toward cathode because at cathode there is a negative charge, and cadmium 2 positive will be reduced here, and iodide will be moved toward anode. Okay, clear? So in the first option they are saying cadmium 2 positive migrates toward anode. No, cadmium 2 positive migrates toward cathode. So this is incorrect statement. Now D statement is also incorrect in this question. They are saying cadmium 2 positive migrates toward anode. So this statement is also incorrect. So we have to choose B or C. Cadmium 2 positive migrates toward cathode and I negative migrates toward anode, and vice versa in concentrated solution. Similarly, so there are two probabilities. Okay, there are two options. Okay, but in the case of concentrated form, cadmium iodide exists as cadmium 2I4. Okay, and it will dissociates into cadmium 2 positive plus cadmium I4 2 negative. So some part of the cadmium is involved in the formation of the complex, that is cadmium I4 2 negative. So that's why transport number of the cation, that is cadmium 2 positive, due to its less concentration, decreases with increase in molality. Okay, so that's why transport number for the cadmium 2 positive is decreased with increasing molality of the solution, because some part of the cation, that is cadmium 2 positive, is involved in the formation of this complex. So in this case also, this is at higher concentration, and cadmium 2 positive will migrate toward cathode, and cadmium I42 negative will migrate toward anode. Okay, and this is given only in the case of C option. So B is incorrect statement. In the C option, in diluted form, cadmium 2 positive ion migrates toward cathode and I negative migrates toward anode. That is correct. And in concentrated solution, cadmium 2 positive migrates towards the cathode, right, and cadmium I42 negative migrates toward the anode. Okay, so this statement is correct in this question. In the next question, the transport number of ions in 1 molar solution of silver nitrate was determined using 0.3 molar solution of cadmium nitrate in the moving boundary method. And when a current of 15 milliampere was passed for 30 minutes, the boundary swept through a volume of 0.1 centimeter cube, and we have to find the transport number of cation, that is silver positive, and Faraday constant is provided here. Okay, and in this question we have to find the transport number of cation. Okay, so transport number of silver ions we can find in the moving boundary method using volume into concentration divided by Q. Q is quantity of electricity used into F, Faraday constant. Clear? And Q is equal to I multiply T. I is current and T is time. So we can replace here volume multiply concentration divided by I multiply T into F. Okay. So volume is L into A, length into cross-sectional area. Okay. So this is known as, we can consider it as a volume. So this will be L into A, its value is provided. Volume is 0.1 centimeter cube into concentration is 1 molar, and current is 15 ampere and time is 30 minutes. We will convert it into seconds. Okay, and value of F is 96500. Clear? Now after solving we will get 0.357, that is almost equal to 0.36. This is our final answer. Okay, so correct answer of this question is 0.36. Next question. Which of the following electrolytes should be given to a chemist to be used as an indicator electrolyte in the determination of transport number of silver positive ions in silver nitrate solution using the moving boundary method? Okay, so to choose the indicator electrolyte in the case of moving boundary method, there are, first is cation of the indicator electrolyte should not move faster than the cation whose transport number is to be determined. Okay, so cation of the indicator electrolyte should not move faster than the cation of principal electrolyte. Clear? And in the second case, for the indicator electrolyte, it should have same anion as the principal electrolyte. So it should have same anion. So anion must be same for indicator electrolyte. Okay. So now we have to check 4 options. Okay. So our principal electrolyte is silver nitrate here. Okay. And according to the second case, anion should be same. Okay. Anion of the principal electrolyte. This is our principal electrolyte should be same. Okay, so its anion is nitrate. So in these four options, in the first case, anion is nitrate. In the second case, also anion is nitrate. But in this case, anion is chloride. So this option is incorrect. In the fourth case, there are two options. One has anion nitrate and one has chloride. So this is incorrect statement also. So we have two options, so we have to pick one as a correct answer. And now in the case of first condition, cation of the indicator electrolyte should not move faster than the cation of the principal electrolyte. Okay, so in these two cases, here cation is cadmium 2 positive, but in this case, cation is lithium positive. And if we compare both cations with cation of, that is silver positive, of the principal electrolyte, in this case, lithium has small size. Okay, so lithium ion has small size, obviously it will move faster as compared to the cation of the principal electrolyte, that is silver positive. So this option is also incorrect. The correct option is A in this question. Next question, consider the following statements regarding structures of naphthalene and biphenyl. Okay, so four statements are provided here and we have to choose correct statement regarding the carbon-carbon bond order. Okay, so in the case of naphthalene, this is structure of naphthalene. Okay, in the case of naphthalene, three resonating structures are exist here. One is okay, so these are the three resonating structures of naphthalene. Now we will give number to the carbons, fifth, sixth, seven, and eight. Okay. Now we have to check the order, bond order of C1 and C2 carbon, C2 and C3 carbon. Okay. So as we can see in the case of three resonating structure here, bond order of carbon 1 and 2, this is single, this is double, and in this case this is again double. Okay, so in overall, in three resonating structures, two resonating structures have double bond between carbon 1 and carbon 2. Okay, one is this, one is this. But if we compare bond order of carbon 2 and carbon 3 in three resonating structure, here is double bond, this is single, this is single. It means carbon carbon double bond for between carbon 1 and carbon 2, there are two times of, in two resonating structures have carbon 1 and carbon 2 double bond. Okay, but only one structure, this structure, only this structure, only one structure has carbon 2 and carbon 3 double bond. It means that is more bond order of carbon 1 and carbon 2 as compared to carbon 2 and carbon 3 in the case of naphthalene. Okay, so in the case of these options regarding naphthalene, carbon first and carbon 2 bond order is greater than carbon 2 and carbon 3. So first option is correct and second option is incorrect. So first option is correct. Now we have to check the resonating structures of a biphenyl also. If we consider biphenyl, this is the structure of biphenyline. Okay, so in the case of biphenyline, there are 5 resonating structures. However, we can consider 5 structures. Okay, in the first case, here should be double bonds. Okay, this is second resonating structure. This is third resonating structure. This is fourth. This is fifth resonating structure. Okay. Now we will give number to the carbon atom. So numbering will be started from this carbon. Here, this is first, second, and third, fourth. Similarly, in this case, we have to also check the C1, C2 bond order and C2, C3 bond order. So we can see that in all 5 resonating structures, this structure contains first of all, we will check bond order of carbon 1 and 2. Okay, this contains single bond, here double. This is again single, single, and single. It means only one structure, only this structure, only one structure is available which contain carbon 1 and carbon 2 double bond. Okay, and if we check the bond order for carbon 2 and carbon 3, here carbon 2 and carbon 3 bond contains double bond. This is single, single, double, single. Okay, so overall 2 structures contain carbon 2 and carbon 3 double bond. One is this and second is this. Clear? So ultimately there are more number of resonating structures which contain carbon 2 and carbon 3 double bond. So carbon 2 and carbon 3 bond order is greater than carbon 1 and carbon 2. So in these options, if we compare these third and fourth statement for biphenyline, third statement is incorrect because carbon 2 and carbon 3 bond order is greater than carbon 1 and carbon 2 for biphenyline, and this is for naphthalene. Clear? So this statement is correct. So first and fourth statement is correct. So B is correct answer of this question. In the next question, the correct order of increasing acidic strength of given carboxylic acids. So 4 carboxylic acids are provided here. One is 4-hydroxybenzoic acid. One is 4-hydroxybenzoic acid. 4-cyanobenzoic acid. 4-acetyl benzoic acid. And 1,4-dicarboxylic acid. So we have to compare the acidic strength of these 4. Okay. So acidic strength is based on the stability of the resulting carboxylate anion. And if we compare the stability of the resulting carboxylate anion after losing protons, here in that case 1,4-dicarboxylic acid will show more stability of dicarboxylate anions. Okay. Here two protons are available. Okay, and that can, after losing two protons, there will be two carboxylate anions which can be stabilized through resonance. So this 1,4-dicarboxylic acid has more acidic strength if as compared to other three carboxylic acids. Okay. So 1,4-dicarboxylic acid has greater acidic strength as compared to other three. Now if we compare these three cases, in this case, in the case of 4-hydroxy benzoic acid, oxygen can show plus R effect here. So ultimately it will decrease the stability of resulting carboxylate anion. So 4-hydroxy benzoic acid has least acidic strength. 4-hydroxy benzoic. If we compare other two carboxylic acids, acetyl group containing carboxylate anion has lesser stability as compared to that of cyano group containing carboxylate anion, because cyano group is strong electron withdrawing group. But if we consider the case of acetyl, however, carbonyl group is electron withdrawing here, but here methyl group shows plus. So resulting carboxylate anion will be less stable as compared to the anion in the case of 4-cyanocarboxylic acid. So 4-cyanocarboxylic acid, benzoic acid, has more acidic strength as compared to 4-acetyl containing benzoic acid. Okay. So this is the correct order of the acidic strength. So in this question, our correct answer is B. Okay, so B is the correct answer of this question. In the next question, the major product X and Y formed in the following reactions. Okay, and there are two benzoheterocyclic compounds. In the both cases, quaternization reaction will be occurred. Quaternization reaction will be occurred because they are providing here 1 molar HCl but only one equivalent. Okay, so one equivalent HCl will be involved in the quaternization of the nitrogen atom in the case of both benzoheterocyclic compounds. Okay, so in the first case, this nitrogen is more basic. Okay, this nitrogen is more basic, and after protonation here, the resulting cation will be stabilized easily through this resonance. Okay, through the delocalization of these pi electrons. So ultimately, quaternization will be occurred on this nitrogen atom in the case of N-methyl benzimidazole. So the exact answer of this will be this, and this option is also available in fourth case, D part. Okay, so C and A option is incorrect here. The correct answers may be B or C. Now we have to check this reaction. Similarly, in this reaction, there will be also quaternization, but in this case, pyridine, nitrogen of the pyridine is more basic center as compared to this nitrogen of the imidazole. So this will be involved in the quaternization reaction, and ultimately resulting positive charge on the nitrogen atom will be easily stabilized by these pi electrons of the aromatic ring. Okay, so this will be your final answer of this reaction. So B is the correct answer of this question, and D is also incorrect. Okay, because nitrogen of pyridine is more basic as compared to the nitrogen of the imidazole. So it will be involved in the quaternization reaction, can easily donate its lone pair of electrons to the proton of the proton which is released from HCl. Okay, so this B is the correct option, correct answer of this question. In the next question, the correct decreasing order of reactivity towards ionization under acidic conditions of the following compounds. Okay, so three compounds are provided here and involve amines. Okay, so in the acidic conditions, obviously there will be H positive. Okay, and that H positive will be accepted by the nitrogen, and so after donating its lone pair to the H positive, there will be ammonium ion. Okay, cation. So we have to check the reactivity of different of these compounds in ionization. So we know that in the first case there is no steric hindrance. Okay, and this nitrogen can easily donate its lone pair of electrons to the H positive and the resulting ammonium ion will be stabilized. Clear? So maximum reactivity will be of first. Okay, first compound. But if we compare these two options, you know, in this case there will be steric hindrance because here is oxygen of the docile group that also contains two lone pair of electrons, and similarly nitrogen contain also one lone pair, so this lone pair will be not easily available to donate. Okay, so if we compare these two cases, third has more reactivity because it in this case there is lesser steric hindrance. There is only one methyl group is available on the nitrogen atom and no steric hindrance around it. So it can be easily available to the proton. Okay, so this lone pair is easily available for the donation. So third has more reactivity as compared to second compound, and first has maximum reactivity towards ionization. So the correct answer of this question is A. In the next question, the products of which of the following reactions are aromatic in nature? Okay, the products of which of the following reactions are aromatic in nature? So the correct option of this question is D. Okay, so all the products of these four reactions will be aromatic in the nature. If we consider the case of first, second, and fourth, in these cases, the parent structure is reacted with, parent compound is reacted with metal. Okay, 2 lithium, obviously it will lose 2 electrons. Okay, and in the case of 2 sodium, it will lose 2 electrons. Okay, and after getting 2 electrons, these structures will follow 4n plus 2 pi electron rule. Okay, and will become aromatic. But similarly, if we consider this case, here this is organolithium compound which will act as base in this reaction, and there is two equivalent of RLI, so it will abstract two protons, one proton from this condition from this carbon and one proton from this carbon, and after that it will have 10 electrons, 10 pi electrons. Okay, and then it will also follow 4n plus 2 pi electron rule. So ultimately the products of all these reactions will be aromatic in nature. So correct answer of this question is D. In the next question, match the pair of compounds from the column 1 with their stereochemical relationship with each other from the column 2 and select the correct answer using the code given. This is structure of M, okay, and similarly N structure is available in the form of a sawhorse. Okay, so we can convert it into This is structure of N. Okay. We can also convert it into wedge form. So we can rotate this bond, okay, of this carbon. Now we can interchange the positions of these three groups on this carbon atom. So here will be CHO, aldehyde group, this will be bromine. Okay. So this is the structure of N. If we consider M, we can also convert this sawhorse form into wedge form. This hydrogen is below the plane and this is above the plane. So bromine is above the plane, proton is below the plane, and this proton is also, that is left side, below the plane, and this methyl group is above the plane. Okay, so we can also rotate this bond. After rotation, this methyl group which was above the plane, now it will be below the plane and hydrogen will be above the plane. Okay. Now we have to compare, this is the structure of M. Okay, we have to compare this structure by this. We can also rotate this bond through 180 degree. Okay, so this structure will be so bromine which is above the plane will all these groups which are above the plane will be below the plane after rotation through 180 degree. Okay, so these are two structures. This is structure of N compound and this is structure of. If we compare both the structures of M and N, we can see that in both the structures, the lower carbon, okay, we can give number to the carbon. The stereochemistry around carbon 2 is same and configuration of this carbon is R and for this carbon is also R. Okay, but in the case of carbon number 1, stereochemistry is different and that's why one has R configuration and one has S configuration for the carbon 1. Okay, and for the carbon 2, both has R and R configuration. So ultimately, these have diastereotopic relation for both structure M and N, and M and N both are diastereomers. Okay, one carbon is R in both case and one carbon is S has R configuration and in the other case this carbon has S configuration. So ultimately both M and N are diastereomers. Okay. So if we consider options, M and N are diastereomers. So for A there is a second option. Okay, so ultimately our A option is correct and we will also check other options. In the case of M and P, we can write M as, this is H, this is bromine, this is wedge form of the M. Okay. For P, you can take its wedge form. After rotation of this bond, lower carbon, we will get this. Okay. Similarly, we will also rotate this bond through 180 degree, and all the atoms which are above the plane will be below the plane, or vice versa. Sorry, here is CS3. Okay. So now we will compare both the structures. In this case, this carbon has S configuration. Okay. But in this case, this carbon has R configuration. And in this second carbon has R configuration. In this structure, second carbon has also R configuration. It means S is converted into R, but R is same. Okay. In both cases. So ultimately both M and P has diastereotopic relation. So M and P are also diastereomers. Okay, M and P both are diastereo. Now we will check other options. Structure of N, we can take wedge form of for N structure. This is wedge form of N structure. Okay. We can rotate this bond as, after rotation, the bond which is above the plane, the group which is above the plane, that is aldehyde, will shift to below the plane and hydrogen will be above the plane. Now this is structure for P. After rotation of this carbon, this bond, okay, through 180, we will get this. Okay. So to compare the structures, we require bromine in the plane. So we will interchange the positions of the substituents of all the groups. Okay. So you can see that both the structures are same. So N and P both are identical. N and P both are identical. Okay, that is one. Now we will check B option. For the B option, structure of M can be taken as this is wedge form of M. Okay. This is for M. Okay. Now we have to check structure for O. So we can also take structure of O, wedge form of O structure, that is this. Okay. After converting it into Fisher form, this is Fisher form for O structure. Okay. And this is Fisher form for M structure. And we can see that both these structures has enantiomeric relation. Both these structures are enantiomers. Both are a mirror image of each other. Okay. So M and O both are enantiomers. So A is correct option of this question. In the next question, which one of the following has an achiral stereoisomer? Okay, so the correct answer of this question is D, that is 1,2-dibromocyclobutane. Okay, in these three cases, B and C both are chiral with no plane. Okay, you can draw the structures, and in the case of this is totally achiral compound. Achiral compound due to plane. In the case of 1,2-dibromocyclobutane, there are two forms. One is cis form and one is trans form. Okay. In the one case, both bromines are in trans position, and in one case, both are in cis position. Okay. And this form is trans form is chiral, but cis form is achiral. So 1,2-dibromocyclobutane has achiral stereoisomer, okay, due to the plane, due to chiral plane. So D is the correct answer of this question. In the next question, the structure which is consistent with this as its IUPAC name is, okay. So in these four cases, first of all, we have to pick both structures. We have to pick that structure which has Z form of alkene. Okay. So Z form, that is cis form. Okay. And in the A and C option, both the alkenes are Z. And this is E form. And this alkene has also E form. For both B and D, options are incorrect. So now we have to choose one from A and C option. Now we have to check the stereochemistry around this carbon atom in A and this carbon atom in C. And if we check its configuration, this has S configuration and this carbon has R configuration. We have to choose R structure having R configuration of this carbon atom. Okay, so according to that, the correct option is C and A option is also incorrect. Okay. In the next question, cholic acid, a major constituent of bile, has the structure as shown below. What are the positions of label 1, 2, and 3 hydroxyl group, respectively, in the chair form? Okay, so we have to check the positions of first, second, and third hydroxyl group in the chair conformation. And for that, we have to draw according to the structure. we have to check position of hydroxyl group in the first ring, that is first. This is second OH group, and this is third OH group. Okay, and in these cases, these methyl and H are cis to each other. This hydrogen and this hydrogen are trans to each other, and there are two hydrogens also that are trans to each other. Okay, so according to that, its structure will be, first of all, we will draw structure of this ring. Okay, first ring. So we know that in these two rings, this methyl group and H are cis to each other, and we will prefer equatorial position of a methyl group as compared to axial, because at axial there will be 1,3 diaxial interactions. Okay, the structure will be unstable, and we know that for 1,2 cis position, one group should be at axial position and other should be at equatorial. Okay, so we will prefer methyl at equatorial and hydrogen at axial. So this is methyl at equatorial and this is proton hydrogen at axial position. So ultimately the second ring will be this. Clear? So if we check the positions of this hydroxyl group corresponding to this proton at 1,3, these are trans to each other at 1,3 relation. At 1,3 relation, in the trans position, one should be at equatorial and one should be at axial. And hydrogen, if at axial position, obviously hydroxyl will be at equatorial. So this is the first hydroxyl group that should be at equatorial position. Okay, now we will deal with the second hydroxyl group, with this hydroxyl group. Okay, and this corresponding to this hydrogen that is above the plane, this hydroxyl and hydrogen both should be trans to each other, and again in 1,3 trans position, one group should be at axial and other should be at equatorial. If hydrogen is at axial, obviously in third position hydroxyl group will be at equatorial position. So second hydroxyl group will also be at equatorial position in the second ring. Now we will deal with the third ring. So in the case of third ring, okay, so this is third ring. Okay, so if we consider third ring, in that case corresponding to two methyl group, okay, both hydrogens, the adjacent carbon atom, okay, this methyl and this hydrogen should be at trans to each other at 1,2 position. At 1,2 trans meaning both should be at same axial or equatorial position. So if methyl is at equatorial, obvious hydrogen will be at equatorial position. Okay, and these two protons, these two hydrogens are trans to each other, and 1,2 trans meaning if one is at axial, other should be at equatorial. So if this hydrogen is at equatorial, this should be at axial. Clear? Now we will check the position of hydroxyl corresponding to this proton. This proton and hydroxyl group are cis to each other. And in 1,3 cis to each other, meaning both should be either axial or equatorial. And this hydrogen is at equatorial position. It meaning that corresponding to it at third position, hydroxyl should be also at equatorial because both are cis to each other. So third hydroxyl group will be also at equatorial position. So all three hydroxyl will be at equatorial positions. So correct answer is B. Okay, so B is the correct answer of this question. In the next question, in which one of the following compounds the anti-conformer is more stable than the gauge conformer? So in this question, the correct answer is C. Okay, because if we consider structure A, B, and C, in these three cases, gauge form is more stable as compared to antiform. Clear? But if we consider the case of 1,2-dibromoethane, in this case there are two bromine atoms. In this case there are two fluorine atoms. Due to less size of the fluorine atom, due to smaller size of the fluorine atom, gauge form is stable. But in the case of chlorine, bromine, iodine, due to large size, antiform is more stable as compared to gauge. So correct answer. And if we compare these for A and D option, in these cases A and D, gauge form is more stable due to the involvement of hydrogen bonding. Okay, so the correct answer of this question is C. In this, due to large size of the bromine atoms, anti-conformer is form is more stable than gauge conformer. So C is the correct answer of this question. Okay, so remaining questions we will cover in the next video. Okay, if you have any query and any issue, you can write in the comment box. Okay, and don't forget to like, share, and subscribe the channel. As I already said that it motivates me a lot. Thank you.